Good day, dear learners. Today we shall look at the particulate nature of matter. We are basically talking about the kinetic particle theory. So you will recall that we have learned that there are three states of matter. We have the solid, we have the liquid, and we have the gases. So this shows the arrangement of the particles in a solid. The particles in a solid, you can see they are regularly arranged. So this is a regular arrangement and they're close to each other because there are stronger forces of attraction. And if you add energy to a solid, this is an example of a solid, this is an ice. If you add energy, it is going to melt. Now it becomes a liquid. And in the liquid, the arrangement of particles is such that they are still close to each other, but not as in solids. And also they are irregularly arranged. And still, if you add energy, it converts to a liquid, to a gas. And the particles here are further from each other. There are almost no intermolecular forces between the particles. So these are the three states of matter. And if you remove energy, a gas converts to a liquid, and if you continue to remove energy, it is going to convert to a solid. So removing energy means you are cooling, and you are cooling. If you are adding energy, it means you are heating. Okay, so solids, let's look at the particles of solids and the forces or the characteristics of particles in solids. Solids have got strong forces of attraction between particles. They've got strong forces of attraction between particles. So let me find a penny. Strong forces of attraction between particles. Particles are packed very closely together in a fixed and a regular pattern, just like you see here. So they are close to each other and they are in a regular arrangement. So when we talk about movement now, atoms vibrate in a fixed position. They cannot change their position or they cannot move. They only vibrate. So that's what happens in solids. Particles only vibrate. Also, solids have got a fixed volume, fixed shape, and high density. So a volume of solid is fixed. In other words, it cannot change. It has got a definite volume, and they also have a definite shape. And their density is higher than the densities of liquids and of their gases, with an exception of water. Liquids, there are weaker forces of attraction in liquids than in solids. The particles are close together in irregularly unfixed pattern. So the particles, you should note that they are still close together, but of course not as in solids, and they are irregularly arranged, just like you see here. The particles here are irregularly arranged, and yet the particles in solids, you see, they were regularly arranged. All right, so particles can move and slide past each other, past each other, which is why liquids adopt the shape of the container they are in, and also that's why they are able to flow. So particles can move, that's first of all, and also they can slide each other. Remember, in solids we said particles, they can only vibrate, but now in liquids we say they move and can pass over each other. They can slide over the other particles. So this gives it the property, the liquid's property of uh, taking the shape of the container, and also enables liquids to flow. Solids cannot flow because their particles cannot move. they only vibrate in a fixed position. Now we move on to talk about volume. Volume of liquids are fixed. That is why if you have a liquid put in a syringe and you close the end of the syringe and you try to compress, it cannot be compressed because liquids have got fixed volume. So it's hard to compress liquids, just like it is hard to compress solids. But they do not have a fixed shape. Though they have a fixed volume, their shape is not fixed because they take the shape of the container, and they have a moderately high density. Their density is lower than that of solids but greater than that of gases of the same substance. All right, let's move on to talk about gases. Gases, they virtually have no intermolecular forces between particles. In the other ones, we said they are in liquids they are weaker attractive forces or intermolecular forces, and in solids they are strong. And now in gases we are saying there are almost no intermolecular forces. Particles are in a random movement. They are moving in all directions, just like you see these particles are moving in all directions. So there is always a random movement of particles, and so there is no defined pattern of their movement. Particles are far apart and move quickly. So they move at almost at a speed of about 500 meters per second in all directions. And particles collide with each other and with the sides of the container. Particles collide with each other and with the side of the container. So the particles will collide with each other. So this particle, for example, is this particle will collide with this one, and maybe with this one, with this one. So, and also they are colliding with the walls of the container. So they are hitting hard on the walls of the container. They are hitting at this speed, 500 meters per second. All right. So with each other and with the side of the container, this is how pressure is created inside a can of gas. So if you increase the kinetic energy of these particles, so they're going to hit more vigorously and harder on the walls, and that is how the pressure increases. Okay, gases have no fixed volume since there is a lot of space between the particles, so they can be easily compressed into a much smaller volume. So you can take a volume from a bigger container, compress it to a smaller container. So they do not have a fixed volume, and they have a low density than the particles, than the density of liquids and gases, sorry, and solids of the same substance. So here I want us to look at the examination tips. Solids, liquids, and gases have different physical properties. The difference in these properties comes with differences in how the particles are arranged in each state, as we have just discussed that one. All right. Now I want us to look at the changes or that occur in states, or the state changes as matter changes from one state to another. All right. So here is the interconvention of solids, liquids, and gases. So you can see we are, as we move up, the energy increases, the heat energy increases, and when as we move down, the heat energy is going to decrease. Okay, so let's start with the downward movement. So we have a gas, we're starting with a gas, and if you cool the gas, you're moving downward. If you cool the gas, from a gas we're going to go to a liquid, and this is a condensation. And then from a liquid to a solid, it is freezing, or we can call it solidification. It is condensation, or sorry, freezing or solidification. We are reducing energy here. And from solids to liquids, let me open from solids to liquids, this process is called melting. And then from liquids to gases, this process is called evaporation. Now there is a direct change from gases to liquids, so to solids, from gases to solids. And that direct change is called desublimation. And from solids to gases, it's called sublimation. Actually, this is another sublimation, so we can call it desublimation, or we could call it reverse sublimation. Okay. Now let us define these processes: condensation, freezing, melting, evaporation, sublimation, and desublimation. All right, let's start with evaporation. What is evaporation? This is when a liquid changes into a gas. So that is evaporation. Evaporation occurs only at the surface of the liquids, where high energy particles can escape from the liquid surface at low temperatures. Now, um, liquids only occurs at the surface. So that's one is very important of the liquid. So if we are having a liquid here on a container, so this is a container, oh sorry, this is a container with the liquid. So this is the liquid. So the liquid is going, the evaporation is not going to occur in the whole liquid, but will occur somewhere near the surface of the liquid. So it's only those particles which are at the top, at the surface, that are going to evaporate, because those particles have high energy, and they are, we say they are excited, and they, meaning they have more energy than the other particles, so they can easily escape from the liquids to the atmosphere. So they can occur actually at any temperature. It doesn't occur at a specific temperature. The evaporation of those particles can occur at even at low temperatures, below the boiling point of the liquid. Of course, the greater the temperature, the more the evaporation. Okay. The larger the surface area, and the warmer the liquid surface, the more quickly a liquid can evaporate. So if you want to speed up evaporation, what you do, increase the surface area, and also you increase the temperature. So that is why, if I were having, um all right, so sorry, okay, so if I were having this example, this bowl, and another one which is narrower, and now I have another liquid here. So this one, which is A, and this one is B. So the liquid in A is going to evaporate faster than the liquid in B, because the surface area where the evaporation can occur is greater than this surface area of the container B. And also, to increase the rate of evaporation, you can increase the temperature. So if it is warmer, it's why it's going to evaporate. Okay. No heat is required, and evaporation occurs at a range of temperature. So we have already said that. Now let's move on to talk about melting. Melting is when a solid changes into a liquid. Now we're changing a solid into a liquid. So let's look at a melting here. So we are changing from solid to liquid. So that is melting. So as we move up, it means we are doing what? we are increasing the energy level. So we are increasing the internal energy. So melting is when a solid changes into a liquid. This requires heat energy, which transforms into kinetic energy, allowing the particles to move. So if you apply heat on a substance, so the particles are going to gain more kinetic energy. And then as they have more kinetic energy, they begin to move faster than before. And as they move faster than before, they begin to spread, to separate the particles, the forces of attraction between particles is going to get weaker because the particles now are moving. So this is going to weakens what the forces. So this is going to weaken the forces between the particles. So it occurs at a specific temperature, unlike evaporation. We said evaporation occurs at a range of temperature. It occurs at a range of temperature, while melting occurs at a specific temperature, and this temperature is known as the melting point of that substance. So it is unique for each pure solid. So uh, like water is going to melt at a specific temperature. It's iron, whatever, they have specific temperatures. So that is if they are pure solids. Okay, so freezing now. Let's move on to freezing. Freezing is when a liquid changes into a solid. Freezing is when liquid, now we have a liquid, it's changing to a solid. We call it freezing, or we can call it solidification. Solidification. So this is disturbing me. Sorry. Cation. All right. So we can call it solidification or freezing. It is changing from liquid to a solid. This is the reverse of melting and occurs at exactly same temperature as melting. So the temperature of freezing is the same as the temperature of melting. For example, melting point of water is 0 degrees Celsius, and, and also the freezing point of water is 0 degrees Celsius. Freezing requires a significant decrease in temperature. So you remember we said melting requires an increase in temperature or heat. And then here, this one, it requires a decrease in temperature. And it occurs at a specific temperature. As we have said, it occurs at a specific temperature. So what happens during freezing is that the decrease in the temperature is going to uh, the make the particles lose their kinetic energy. So they then become lazy. I will say they become lazy and move slowly, gradually decreasing until then come to very close to each other, and then the solid forms. So that is what happens during freezing. Okay, so let's move on to talk about sublimation. When a solid changes directly into a gas. So this is sublimation. This is when a solid changes directly into a gas. This happens to only a few solids such as iodine or solid carbon dioxide. So it's not all solids that sublime. It's a few solids that do not convert to liquids, but they just convert directly from solids to gases. So the reverse of this reaction is called desublimation or deposition, or we can call it reverse sublimation. Sublimation occurs at a specific temperature, just like freezing and melting, they occur at a specific temperature. Condensation. Condensation is when a substance turns from gas to a liquid. It turns from a gas to a liquid. For pure substance, the condensation occurs at a specific temperature. Now we are having a gas, and then the gas converts to a liquid. So we call this process condensation. So the gas, you remember the gas particles have high energy or have high kinetic energy. They are moving randomly at a very high speed, and now if you cool them, their speed is going to decrease, and they begin to move closer to each other, and that creates that because of the created intermolecular forces between the particles, and then they come close to each other. So during condensation, the temperature remains constant while the bonds reforms. This is giving out energy in the process. So if we are cooling a gas, the temperature decreases, and when it reaches the condensation point, the temperature will stop decreasing. It will just remain constant for a while. Why? Because the energy is now not used to cool the temperature of um, the substance, but it is given out in the process as the forces or the bonds reform. The condensation and melting point of a stuff. Oh no, so it's not melting point. This one is supposed to be boiling. Sorry for that. So this one is boiling. So it's not melting. So the condensation and boiling point of a pure substance are the same. All right. Boiling. Boiling is when a liquid changes into a gas. It is when a liquid changes into a gas. So it's almost similar to evaporation, but we are going to explain the difference between boiling and evaporation. So boiling requires heat, which causes bubbles. So in boiling, there are bubbles that form, while in evaporation, there are no bubbles that form. So the bubbles, which cause bubbles of gas to form below the surface of the liquid, allowing the liquid particles to escape from the surface and within the liquid. Now, so in evaporation, we say it occurs at the surface, but now boiling, the evaporation of particles is going to occur even within the particle, because there are bubbles that form. So those bubbles contain the gas, the liquids that have converted into gases from within, and then they are moving up so they could escape. So boiling occurs at at a specific temperature, which is called the boiling point, and it is unique for each pure substance. All right, so this is a heating cave, constant temperature during change of state. So usually when a substance is heated, its temperature increases. However, whilst a substance changes its state from solid to liquid or from liquid to gas, the temperature of that material remains constant, even though energy is still added. So now let's look at this one. So this graph shows this time, and this one shows what temperature. All right, that one shows temperature. So here the solid is being heated. So as the temperature increases, we can see the solid is being its temperature increase from this point from here to here. So the temperature is going to increase, and then at a specific time, the temperature doesn't increase. The temperature of the solid now remains constant. When this is during melting, the temperature it doesn't add the addition of the heat doesn't add the temperature of the substance, because the temperature now is being used to break the bonds between the forces, between the particles. It's used to break the attractive forces between the particles. And when all the solid has melted, it then begins to the temperature begins to increase again, and then at a specific time or temperature, the it stops increasing, and then it's boiling occurs. So you can see boiling and melting and boiling occur at specific temperatures. So the reverse of this is, we could call it a cooling cave. So this one is a heating cave. So it will take the same shape. Okay. All right. When substances change state, its temperature remains constant, even though it is still gaining or losing internal temperature energy. So this is what I explained. This happens because the energy is being used to break bonds between the molecules instead of increasing the kinetic energy. So here at melting and at boiling, the energy was used to break bonds between the molecules instead of increasing the kinetic energy of the molecules, and hence the temperature. When a substance turns from a gas to a liquid, that is condensation, or from liquids to solids, that is solidification, the opposite happens. The temperature remains constant while the bonds reforms, or they give out energy in the process. So that is why we're saying when a substance changes its state, its temperature remains constant even though it is still gaining or losing. So this example is gaining, and this example it's losing. There it's losing internal energy. So yeah. The melting and boiling point of a substance is that the temperature at which that substance changes its state. For pure substance, the following changes occur at the same temperature: melting and freezing, boiling and condensation. So we have said that. All right. So a summary of this: we have a process. What happens to heat energy? Is it exothermic or endothermic? Exothermic is when it is releasing energy, or energy is lost. Endothermic is when it is gaining energy. So melting is it's what the heat is gained, and therefore it's endothermic. Boiling, heat is gained and it's endothermic. Condensation, heat is lost and it is exothermic. Freezing, heat is lost, it is an exothermic. Sublimation, heat is gained and it's endothermic. And reverse sublimation, heat is lost and it's exothermic. All right. So I want us to compare boiling and evaporation. Boiling occurs at a fixed temperature, while evaporation occurs at any temperature. Boiling happens throughout the liquid. So the liquid, some gases come from within, while evaporation occurs at the surface. It's only at the surface of the of the liquids that evaporate. So during a boiling, bubbles form. So these bubbles are the gases that come from within, or and then the liquid that comes from within the liquid. And in evaporation, there are no bubbles that form. So examination tip is that questions on the particle theory of matter show interconvention of state with a reverse arrow, which means that the process can go forward and backward. Read the questions carefully and pick the direction of change instead that the question refers to. Thank you very much.